My name is Sesh, and I'm the Chief Evangelist at Aerospike. I'll tell you in a little bit what Aerospike is about. But today I'm going to be talking about fighting financial fraud in real time with AI. Okay, so that's the topic. Where is it? Okay, so here it is. Am I pointing in the right place? There you go. Okay, so we'll talk about, modern fraud defense. I'll give you a quick introduction to Aerospike and then also talk about how Aerospike is an ideal data infra for fraud, okay? So that's the goal. Oops. No. Okay, so fraud is really an arms race that's going on right now, People believe anywhere to 1 to 10 trillion, depending on who you believe in terms of estimates, is being lost or at least being spent, in fraud. So there's a lot of money at stake, and if you are, of course, one of the people who are responsible for protecting fraud, you know that. And in most of these cases, milliseconds probably are going to determine millions. So it's a matter of few milliseconds that's going to make a difference. And you are dealing with more and more sophisticated adversaries. People are becoming cleverer and cleverer. They're using technology, they're using automation, they're using AI themselves to commit fraud. So that's the arms race that you're up against. And finally, the classic paradox or challenge that you have to deal with here is you want to make sure your customer experience is as smooth as possible. So you don't want people realize or getting rejected for valid reason, for valid use cases, but at the same time you need to protect. So it's a paradox, right? So you don't want to penalize good people, but you want to catch all the bad people. Okay, so that's the crux of the thing. So you can't let a single fraud transaction go through. And this is really going to be a competitive advantage. Anybody who nails fraud at low latency in their sector is going to be a leader, right? So it's a true a distinguishing advantage. And AI is in a critical path for any anti-fraud solution. You got to make decisions in line, which means you're not going to detect fraud post facto. You want to detect fraud as it happens, when it happens, before it happens, actually, in particular, right? So that's the key. And you have milliseconds to do this. So you don't have days, you don't have hours. So you got to make these decisions in milliseconds. And typically, when you're in the internet or you're swiping a credit card, at a POS, there are about 50 milliseconds. That's all the end Visa or Barclays Bank or whoever gets to detect fraud, or PayPal. And tail latency is super important. It's not enough to say, okay, 99% of the fraud I'm catching, but 1% I'm letting through. That 1% is a huge number. And we'll talk, we have examples where we have taken something that was 98.5 to 99.9 or something, and that makes a huge difference. Okay, now we'll talk about how the fraud maturity stack has built over time. I think, when this whole thing started, it was all probably based on static data. Some intuition, people or these kind of businesses lead to more fraud, those kind of things, very, very static, to saying, okay, let's create some rules, if this happens, then likely to be a fraud, to machine learning, which we'll look at each one of these, where you are actually trying to make cleverer prediction, to using graphs and so on and so forth, and we'll come to that. So which is the modern way of dealing with fraud, machine learning and graph together, okay? The rule-based assessments typically tee off some static set of things. Could be, hey, this person has swiped his credit card 5 times in the last 5 minutes. They're not in the location that I expect them to be. They're transacting with merchants that I don't think are sort of highly susceptible, and so on and so forth. So you could have any number of reasons. But the point here is that this is endless. It's like trying to plug a sort of a dam with duct tapes, or plug a dam with your 10 fingers, and hoping that you can keep the water away. It's just an endless sort of things. So people definitely evolved from this, and then they went to what's called machine learning inference. And I'll talk about how we get used for machine learning inference, and in particular what's called a multi-step inference, and so on and so forth. But at a very high level right now, machine learning inference is all about continuously learning, continuously training, retraining, and that's how you adapt to evolving threats. You're ingesting hundreds of features simultaneously, and then putting all these features together, sort of all these signals are coming together, and then you're trying to make some sense out of these signals. So there is a holistic signal fusion, if you will. And machine learning basically learns what's called the optimum decision boundaries. There's always some kind of a decision boundary where your decisions are optimal. And it's the challenge for machine learning is to learn these optimal decision boundaries. And that is what helps reduce false positives and false negatives. Okay? So, because that's what is going to get you remember the customer experience versus security trade-off comes from false positives and false negatives. So, and machine learning finally discovers hidden complex fraud patterns. So it helps you detect the unknown unknowns. We'll double click into this as a data infra. Here are some features, that people use in fraud detection. I'll talk more about it later. The next step after machine learning is, can you actually help the fraud detection engine with what I call some clever feature engineering, right? I mean, those of you who do machine learning know that feature engineering is an important component of good machine learning. So, and in this particular case, it turns out in the fraud case, graphs are a very useful construct to think about. Because a lot of the fraud that happens in networks naturally. So there are mules, there are rings, all this collusion happens naturally in networks or graphs. And any single transaction may look okay in isolation. It's actually the conglomeration, if you will, of all of these things together that sort of causes challenges. So really, it's all about connections and relationships. And what graph analytics does is it exposes these hidden structures. It says, okay, here are some communities, here are some connected components, and maybe, and those are sort of places where you want to pay more attention to. So this is definitely sort of the next level. And even more is to take this whole graph notion and make it real time. And it's important to understand this. Machine learning training takes time. People may train, even the fastest of the training sort of pipelines may do it in hours, maybe if you're really, really fast, sometimes 15 minutes. But fraud happens in seconds. Okay, so you need to know what happened in the last second to actually get to fraud. So what this is saying is you really need a very fast, what shall we say, ingestion pipeline, and you need to sort of organize it as a graph. And you need to detect that a fraud is happening over a multi-hop sort of a situation where you're laundering money over a multi-hop. Okay. Again, happy to talk more about this, but the point that I want to leave you here is machine learning is super critical, and you want to build real-time graph capability on top. Okay, so that's the real point I want to leave. That's the cutting edge of how you detect fraud today. I'm going to go back to machine learning now a little bit, but before that, let me give you a quick introduction to Aerospike. Okay. So, why Aerospike for fraud detection? And this is true not just for fraud detection. Of course, Aerospike is applicable for recommendations, for various predictive AI applications, various other applications. And what I'm saying is generally true for all of that, but we will draw upon companies that in particular have solved fraud with us. The first and the most important reason Aerospike is very important is it provides very high throughput at low latency at very high reliability. So getting all these three in combination with a few other things we'll talk about is a key reason why Aerospike is very valuable. And that's why we power mission critical use cases and workloads, whether it's PayPal, whether it's TransUnion, and again for fraud detection in all these contexts, okay? The second reason is we do all of this throughput, latency, reliability, while reducing the cost of ownership at the lowest cost of ownership, and we'll touch upon this a little bit more. But Grab and LexisNexis are several examples of where there was a reduction sort of server capacity, 70%, 80%, that kind of server capacity reduction. And of course, it's optimized for machine learning and AI. So I'm going to now dig into a few reasons why Aerospike is able to deliver this performance and give you examples of what kind of value it's able to provide. And the most important reason why Aerospike delivers this kind of performance is its patented hybrid memory architecture. And the crux of our hybrid memory architecture is that we are able to beat databases that store data in RAM or in cost and match their performance. We are able to beat databases that store data in SSD in performance while matching their cost, right? So if you see, we're kind of on the left corner, high performance, low cost, and that's really the calling card. So a few more examples. This shows how Aerospike gives you what's called predictable low latency. You remember I talked about tail latency right up in the beginning when I said it's not enough to catch 98.5%. You really want to catch 99.99%. That's what this is talking about, right? So, so you're kind of, here is another system that has a very high variance data stacks. And if the variance is high, the average is high. Whereas Aerospike, the variance is low and the average is low. So that's the real key. Several places where we reduce the database cost by 80% or so. Specific examples going from 40 to 6, 400 to 60, 450 to 60, 3,000 to 720, and so on and so forth in several situations. And one last slide that sort of introduces Aerospike, which is Aerospike also happens to be an excellent at having a core and an edge kind of a architecture where you can have a core where you're doing all the training, and the trained information or trained features, if you will, are sent to all the edge clusters, which are very close to the where the user is and where the transaction is happening. So that's how you reduce your response time. Okay, so now let's look at why Aerospike is the ideal data infra for fraud. Okay, and to understand that, we need to understand how a typical machine learning architecture looks like. Okay, so if you notice, so data sort of comes from flows, if you will, from right to left. So here is offline or batch data that might come. I mean, this might be any kind of data. Maybe this is data from other partners that you have, and so on and so forth. That where known fraud has been. There is some information that you have unearthed. Maybe addresses, maybe your credit score. It could be any number of things that could be coming in a batch mode from outside your system. And in real time, people are transacting with you, and that's also important, right? So they're actually transacting with you. So in real time, what happens, whatever is transacting is getting ingested, and maybe it becomes features or state store or whatever that gets stored. And this yellow stuff is where, this is Aerospike. So things get stored as a state store as things come in real time. And the batch mode is basically this training sort of pipeline, if you will, where the features are getting generated, and the generated features then get back into the online feature store. So this is the online feature store. And the same sort of Aerospike database can be used as an online feature store, as a state store, and as an inference cache. Okay? It can be used for all of these things. And what happens during inference time is a transaction is initiated here. There is an ML inference engine which consults Aerospike database, and it might initially just consult it and say, hey, do I already know the answer to this because I've already made this inference? Or what latest information do I have? Do I need to build new features on the fly? or, okay, I'm done with all the new features. Now I'm going to use all these features, make an inference, make a yes, no decision on the fraud. So that's what is happening, okay? I'm going to sort of go through a very concrete 3-stage fraud detection pipeline. So that was a general end-to-end pipeline. Now I'm going to talk only about the inference part of things. So the core inference part of things here is in 3 stages. And the way to think about it is inferences and decisions are going to be better if you had more data, if you threw more data at the problem, and if you put more complex models. I mean, that's a given. So if you can put more complex models, or if you can give it access to more data, then inferences are going to be better. However, it's not possible to run the best model on all the data all the time, okay? So typically, people, what they do is they do this in multiple stages. In the context of fraud, what's happening is you might have a rules-inspired model. The model is, logistic regression, something like that. Approximately 70% of the cases are going to get done in less than 1 millisecond. Then there may be something that's of intermediate complexity where you're catching 20% of the things in approximately 5 milliseconds. This is basically an example of this is, there is an auto pay to, PG&E is our utility in California, but take your favorite utility, and you're doing this every month. So it's unlikely to be fraud, okay? It's the same transaction, you do this every month, it's an auto pay. Here is something that it's in your neighborhood, you've been here, you've been purchasing things. So yeah, maybe a little bit more, maybe a new store, but still in your neighborhood, pay attention. This is something that you don't normally do, it's out of the ordinary, so pay more attention here, right? And that's going to happen in about 15 milliseconds if you're out there, let's say. So this is an example of a multi-stage pipeline. And this leads me to this, probably the most important slide of this presentation. The one that frames why, for a multi-stage inferencing process, Aerospike is a great fit. So I just want to preface that. Also my last or second last slide. So what this picture is trying to depict is, think of this as a basic feature store, and think of this as the Aerospike being used as an online feature store in an inference process. So your entire inference has about let's say a fixed budget of 50 milliseconds. Let's pretend that this is not necessarily to scale in the sense that this feature store lookup is of the order of 1 millisecond, so it may not be 50 times, but give me that poetic license. So what this is showing is, the basic feature store maybe takes about 5 times this, or 6 times this, or 7 times this to look up anything. So that's what it takes. And then you might do the rules-based setup, the most simplest thing that I talked about. Then again, you look up the feature store, and then you might do the second step, which is the intermediate risk step, and you run out of time, okay? And in all this, you might get access to some amount of data, which is the y-axis here, the vertical axis. In Aerospike, you can get access to a lot more data, okay? And also do a lot more steps, because what you have done is you have reduced this time dramatically. So essentially, if you look at the area of the blue things, that is the time that the data infra returns to machine learning or to decisioning. So essentially, bottom line, what's happening is the data infra is able to give the machine learning and other things a lot more time. And so that's the key. So more time for modeling, more modeling steps, and more data to model. That's what happens. Okay, I will leave you with a quote from one of our customers, which kind of probably says this more eloquently than I can say it, which is it allows us to do more complex risk calculations in less time. And so that's really what it is, right? So I couldn't have said it better. Okay, now I'm to the end of my talk. I'm going to sort of give you a few things. We are in booth 118, right next door. So please visit us if you have not. And if you have questions, you can come talk to us. Our founder, Srini, is here, and he's going to be giving a keynote tomorrow at 9:30? 10:30. At 10:30. So please come by. And finally, we also have the same place, I believe, we have a fraud demo. We're performing a fraud demo, and that's going to be in this place at 11:15. So lots of opportunities to meet us again, and we'll be standing by in the booth if you want anything more. But I'm going to stop here and maybe take a few questions.
So you guys both in your pipeline, you
So the question is, are we more of a data pipeline? I would say we are more of a database in the sense that we are the place where the data is stored. So we are the online feature store, we are the state store, or the session store, we are the inference cache. So the plumbing might happen through other things like Kafka or whatever, right? So you might bring data into Aerospike through Kafka. You might also take data out of Aerospike, but we are the database. The best way to describe it is we are the real-time database. We are probably the first database you will meet when a customer transaction comes from the internet. So we are the database. That's where all real-time decisions get made. There might be other analytics databases and warehouse databases farther behind on which training may happen, but this is where data required for real-time decisioning stays. We don't train the models. We actually are only a repository of information. The information, like I said, could be feature store. So somebody else, meaning our customers build their own models. They train features and they load those features into Aerospike. Any other questions? I can't see too well, so yeah. Okay, yeah. So how do we do what? Sure. Again, there are two contexts in which you could be asking this question. I mean, first let me answer one context, which is many places Aerospike is something that customers manage themselves, right? So the database is within customer premises, and obviously there are security, things are encrypted, and there is RBAC and so on and so forth to access the database. This is standard enterprise access to a database. We also have what is called a hosted version, and then there we have to go through, there are various security guarantees, SOC 2, ISO compliance, blah, blah, blah. So both models are possible, but a lot of our leading customers today actually manage the database themselves. Cool. Thank you.